So my name is Fred Melo. I've been at VMware plus Pivotal for around 5 years now. It's been a very exciting journey to see Cloud Foundry grow as this incubation project inside VMware. I still remember the old alpha days. You used VNC command instead of CF to push your applications to. And see this after a few years to become de facto standard for platforms. It's really great. But more important than that, I think that now it will start to get more enterprise-wide use cases with enterprise application integration using Spring cloud-native architectures on Cloud Foundry. That's where it gets extremely exciting, and that's exactly what I'm here to talk about. Twitter handle, if anybody wants to be friends, let's talk about that. So, if you look at the last 2 decades mainly, the entire software industry is progressing from waterfall development methodologies towards agile, lean, continuous integration, continuous delivery, continuous deployment, not necessarily in the exact same order, but going from a point where actually enterprise take maybe a year from the concept to a very, very simple application to the point they're able to get all the pieces together and do all the heavy lifting to be able to deploy that. And points that companies like Netflix today deploy several times an hour, actually at each few seconds, and they're able to actually iterate on that code much faster, get use feedback as soon as possible, you actually really improve the process, the progress, and deliver best user experience possible. So all companies are actually shifting towards that and trying to do it. What we actually learn through the path, that all those movements have one thing in common. They're actually only looking for more frequent release events that actually carry much less risk. If you watched OnC's keynote, you know exactly what I'm talking about. But from an implementation perspective, we also see that if you really want to do that, if you really want to deliver software faster, the traditional architecture that we've been building our systems for the last 3 or 4 decades, it's not good enough. If you really have this huge development team try to work on a single application that has so many things inside, it gets extremely hard to coordinate all that effort to releases. It gets extremely hard to test the system as a whole. It gets extremely hard to animate modification that's not impacting the entire system. And that's why usually companies take months or years from a concept to production. And if we want to go faster, we learn through the way that one of the best approaches is actually start decomposing those giant monoliths in small applications that have a single responsibility, are usually developed by a small team of developers. At Pivotal, usually work in pairs. So a few pairs working on small piece of software. They actually have a bound context. They expose their very clear contracts or APIs to have those services consumed by other applications. And then you can now start iterating on those small pieces with very real impact or no impact to the other applications, continue you keep the contracts. And now you can actually scale them independently, et cetera, et cetera. And if you're able to do that, and you have on a platform like Cloud Foundry, it makes it extremely easy to just come with a microservice, just push through Cloud Foundry, so you have the application does all the heavy lifting for you, and then it just works. That's how we work inside Pivotal. That's how we're trying to work with our customers. And I'll tell you the vast majority of them is start with a new greenfield project, something that's not necessarily connect to the rest of the world, to have this first quick win, easy example, experiment the platform, see all the benefits of the platform. However, there's always however, after they have this first successful implementation, where they can actually have services that can able to upgrade without downtime, scale demands, sometimes auto-scale, redeploy, migrate, distribute across any cloud, but they look at the rest of their architecture and see, oh, now how do I really go cloud native on an enterprise architecture point of view from end to end, right? We know that no system is an island. So we can start with that greenfield project. We can work with that. We can show that quick win. we can show the best way to develop software. We can actually deploy the platform, make people amazed about it. But if we can't really connect our legacy, if we can't adopt cloud native from end to end, if I'm only able to do continuous delivery in that small piece of my architecture, are you really delivering that much value? So this is usually the kind of conversation that we get in the customers. They already started the journey, are developing microservices, are adopting Cloud Foundry, but are really looking for the next step. And as we look for the next step, we can start, as I said, taking a small system, iterating on that, and now I can start going cloud native. I can adopt DevOps to that small piece of architecture. And then you look back, you have maybe System A and System B in this example, traditional monoliths, maybe a decade old, with their own giant relational database that is completely necessary to represent their entire data model that is extremely complicated because they have so many things going on in the same application. Those relational databases, along with their applications, are not able to scale horizontally, of course. They just don't deploy in containers usually. It's really hard to do any modification. And if you start to look at what happens with data, then in my own point of view, that becomes nasty. Because those systems, they usually have their own relational database that they transact during the day. But then what happens in the end of the day? Well, they usually replicate that database for maximum high availability to different sites using very expensive solutions, like Oracle GoldenGate, for example. And then they take all the transactions, they crunch it during the night on their nightly batch jobs, and then they feed the analytical systems. What a perfect scenario. But they have two big problems. If you're really doing that, and I'll tell you that at least 80% of the customers I talk to are, you're analyzing yesterday's data. And that's issue number one. If you're really feeding your analytical systems with batch processes overnight, the only analytical insights you're getting are based on yesterday's data. And how do you want to do what Uber does, for example, that is real-time analytics to see offer and demand to suggest search prices? Or how do you expect to do what Airbnb does? First time you advertise a place there, you have no clue how much to ask. Compare similar places with the same characteristics, but takes in consideration seasonality, the immediate offer, the immediate demand to suggest your fair price. If you really want to do anything that is real-time analytics, real-time machine learning with data, then how do you actually get those insights back to your microservices? If you're able to do real-time anyway, if you're not doing analyzing yesterday's data. So at Pivotal, this is one of the next problems we are tackling right now with Spring, with Cloud Foundry. And that's the problem that leads us to the concept of data messaging microservices that we're basically talking about. So how do we take this and actually have a microservice-based approach to solve that problem? It all starts with analyzing what an anatomy of a typical integration pipeline. Usually you have sources of information, several sequential steps, and then a destination, or we used to call it a sink. So I'll give you an example. You can have your old system, your mainframe, your third-party system, let's say, send you a file, and I hate file-based integrations, but those still exist. Send a file, for example, and then you have an integration process that gets to that FTP server, grabs that file, and then first step usually parses it. And as part of parsing, you might get back a CSV, a JSON payload, or something like that. Next step might be, maybe if you got a CSV, convert into JSON or something that you can work on. So that's the second step of the processing. Third step might be, I'm going to enrich it with some data coming from another system. Enrichment is something extremely common in enterprise integration. All those ESB use cases. Next step, you might, for example, do some distributed processing. Spark is very sexy. People are trying to use Spark all the time to do distributed processing of data, crunch data, come with their pre-format data for example, feeding their analytical models. And it's something that we're going to do live in a few minutes. And then your destination last step might be, I'm going to put this on my memory data grid. I'm going to deliver this straight to my applications from message bus. Or I might land this data on a relational database, my analytical database, something like that. The same applies for any kind of IoT-based scenarios, for example, that you can be feeding information. This time is the streams all the time through this channel, getting from sensors, for example. And then I might want, as part of my pipeline, look at historical data and come with real-time recommendations. So we have a very well-known use case, for example, that have been helping GE on taking a look at all the sensor data coming from turbines and then be able to get data insights. So for example, based on historical data and this oil temperature and this vibration of the engine, last time it happened, you had an urgent maintenance call in the next hour. So we might be ready to do some preventive maintenance on this. So anytime we're integrating data, moving data from one side to the other, connecting legacy, existing microservices, data from some place, we can actually have an integration pipeline. The problem with existing integration pipelines are the same with any monolith, right? Can you just redeploy part of that pipeline, one step, without downtime? Especially when you start doing data science, there's a lot of experiment going on. And if you can't really deploy parts of that integration pipeline, there might be, for example, your machine learning algorithm that you're going to evaluate, you're in a big problem. You're really going to bring downtime to your customers for some experiment that you could be doing as a blue-green deployment, for example? You don't. Not all steps of that pipeline have the same scalability needs. I will tell you that process that goes grab that file, you really only want one of that because you don't want any concurrency on accessing that file. However, from that point in time onwards, you want the maximum parallelism as possible, most of the times, to be able to process data fast. Maybe your transformation part, that access Spark, you want really to scale to several different containers, but for some parts of it, you might want to save some infrastructure. So they have different scalability needs. Can you scale those pieces of your data integration pipelines or system integration pipelines independently? Usually not. And then day two operations, when you're really running in production, and that runs on top of operating system, as most things that we have, and that comes that you have a security patch to apply to operating system in the middle of the day, and the security guy in the company tells you, you have 3 hours to apply that patch. What do? Well, you usually take the systems offline. That's why sometimes you try to access your enterprise systems. Oh, sorry, earn the maintenance. This is not acceptable anymore in enterprises. So that's why we're taking a different way and taking this integration pipeline and start to imagine every single step as a different piece of software that does exactly one thing right, has a very clear contract, and then people can iterate on top of, like any applications they develop. So you can imagine your source as being a microservice, your destinations as microservices, and any additional steps as microservices. And then all you need is basically a messaging transport that connects the output of application A to the input of application B, and the output of B to the input of C. And then you have a continuous data flow. You can actually trust usually the messaging middleware to provide the high availability capabilities for that transport. But you want to have choices. You don't want to write your systems making a 10-year commitment to a specific messaging technology. It's another problem. And we are tackling all those problems with a project that's called Spring Cloud Stream. So how many of you are using Spring Boot? Or, okay, I don't need the or. 80% of the room. That's great. So you can take any Spring Boot application and with the help of two very simple annotations, convert any Spring Boot app on a data microservice. And that's what a Spring Cloud Stream application is. It's a Spring Boot app that has an input and an output. So imagine that any simple application that you have with a main method will receive some parameters and return something. That's the contract of the microservice usually. Very simple. I receive this, and I expect to return that. Has exactly how you unit test your microservice as well, of course. Imagine if you can just tag that microservice and say, you know what? Those parameters are coming from a message layer or a messaging bus. And I don't care which technology or which messaging bus you're using for that. And when I return a result, I want to return back to the messaging bus that will connect to the next Data Microservice. But I really don't care on where I'm returning either. I want the framework to figure it out for me and bind it automatically for me. And that's the build of Spring Cloud Stream. We'll do that together, so it's going to become much clearer for you. But if you just take a Spring Boot app and say, this method, I want to be the contract of this data microservice. So this method might receive a CSV payload, for example, and return a JSON. That conversion microservice I give as an example. When you tag that and you say, deploy this to my cloud, Spring Cloud Stream will make sure that it binds those microservices, they are now calling messaging data microservices, to an existing service available in that cloud implementation or that platform, and then everything works. So you can imagine that you might develop your microservice just developing the business part of it, or the behavior expected to make, and in runtime, the framework will go ahead, will, for example, connect to RabbitMQ, create an inbound queue and outbound queue, connect those things together, and do this for all your microservices so they actually behave a continuous stream of information. But there's more. Because once you deploy that in Cloud Foundry, each of those just become another microservice or application in Cloud Foundry. And the beauty of that is because now you start getting logs for all the applications aggregated on the exact same way, on the exact same place. Makes it really easy for operational usual things, for troubleshoot, for root cause analysis. If you have an issue, don't need to SSH to every single of the containers or servers to see what's going on. You get all the logs same location. If you kill an application, it restarts automatically. You can turn on auto-scaling, and it figures out when it needs to add a new instance. You have all the metrics, same location, integrated monitoring, and everything that you get for an application in Cloud Foundry. It opens pretty interesting possibilities. You can actually start using other services in Cloud Foundry as part of a data microservice. Maybe part of your pipeline needs to make a decision if a certain service is available, otherwise you route the information in a different way. It might be a good idea to use circuit breakers for that. So it opens a wide range of possibilities that now you can actually iterate on small parts of integration pipelines like any microservice. And as you deploy those data microservices, for example, to a space in Cloud Foundry that is your development space, you know, maybe it's just a functional testing. So maybe all you want at that point is an in-memory connection between those data microservices on a single machine. So maybe you want to use Redis for that. But really, when you want to deploy to production, you want full scalability and performance, and then your implementation might be Kafka. And you don't change, you don't touch the source code. Spring Cloud Stream figures out how to bind it to different services depending on different circumstances. So those are the very simple two annotations that we'll need to convert anything to a data microservice. And in a class, we're going to do that together again. As I said, there's some live coding here. But at the very class level, you just say, this is a processor, or this is a source, or this is a sink. It's really simple. A processor has both input and output. A source generates data, so only has an output. And a sink only has an input because you know what to do with output. It's very simple. So just say, this is made to be a source, a sink, or a processor. And then on the method that you want to use, you say, this is a service, and activate this by this input. And if you use processor.input, for example, is the standard, it will bind it automatically to a channel it creates on the service implementation. And the same we'll do with the output. So it makes it really simple. I know it's a lot of information, but we'll base ourselves on a demo, and it's going to make all sense in a few minutes. But there's more. So I'm talking about primitives. Small pieces of application that you can actually convert to a step on a processing pipeline. That's it. Primitives. Spring Cloud Stream. Small primitives, like Spring Boot applications. The problem is, those pipelines get complicated a lot of times. And you want to be able to manage the life cycle of those. And you won't be able to deploy all at once. A pipeline missing pieces doesn't make sense. You want to be able to actually have some visual interface to draw those processes, because it makes a ton of sense when you're integrating end-to-end. People want to have that clear architecture picture of the integration. So we launched a project called Spring Cloud Dataflow. And what Spring Cloud Dataflow is, it's an orchestration layer on top of those primitives that I just introduced you to. So Spring Cloud Dataflow is what we're going to be using in a few minutes. But with that, you can, for example, come with a visual pipeline definition that I might be ingesting data from this HTTP source, for example. It might become a different format. Now I can convert it to JSON and apply some filtering. Next step, for example, I can do a transformation that will be invoking an external Spark job. Then I might want to split my process in two, because they can go to two different directions. But the awesome part is, if I click deploy, Spring Cloud Dataflow makes sure that he's going to go ahead in Cloud Foundry, create those Data Microservices applications for you. That can be a mix of applications you're reusing, somebody else created. So I would expect, for example, myself to do this demo to create a JSON filter application. That, for me, would seem very standard. Something else should already have worked on it, and it doesn't make sense. I expect to be able to create very custom things specific for my needs. So Spring Cloud Dataflow allows you to orchestrate existing data microservices, which are own pieces that you create if you want, put them on a design pipeline, and when you hit deploy, it goes ahead, downloads those, push them to Cloud Foundry, find an available service messaging layer they want to connect to. In this case, it can be Kafka, for example. Connects to Kafka, and then it just works, like any microservice you CF push to. If you go to Spring Cloud Dataflow, there are very, very simple use cases you can get started with. I don't want to bother you with another simple example. We're going to be doing something really fun. So that's the scenario I'm suggesting. We have a microservice representing a POS for credit card transactions. So it's generating random, let me say pseudo-random, and I'll explain why. Transactions coming from different devices. And I purposely made one device per US county, so we can have an even distribution on a map that I want to show you. And I'm going to be generating random transactions, like many POSs, and sending them to a fast data layer, or a scalable, horizontally scalable in-memory transactional layer that can take those. But I just don't want to have another microservice that looks and shows where the transactions are. We want to be able in real time to identify which transactions could be possibly fraudulent or not based on machine learning algorithm evaluation. That's real time. So hopefully we'll be able to do this in half an hour. And then you tell me how much it would take to do that in your existing enterprise architecture. Deal? Okay, let's go to it. So that's what I expect to see in the end. Some orange, reddish, and some green transactions. So we'll start with that setup. I have a microservice that's just a Spring Boot app that we're going to run that trades those transactions. We're going to see those transactions happening. Those are transacting to Pivotal Gemfire. It's an in-memory data grid. Scales extremely horizontally, handles those transactions really fast. And then I have another application that is connected to JFAR, and we'll see those transactions, show them on a map as we have a correlation between the device ID and the US county. If you realize at that point, I'm not doing anything fancy. There's absolutely no analytics, no machine learning, nothing happened at all. That's just our baseline. So I'll just show that working. And by the way, JFAR is automatically writing behind Greenplum all the transactions happening. And Greenplum, it's a parallel analytical database based on open source Postgres. So it's an open source MPP. And we're going to use that later to train our model. Of course, if you want to train your model over historical data, you need something that not only has enough power to store historical data. JFAR is an in-memory data grid. You usually store only hot data on it. And also supporting analytical queries, distributed queries, etc. We'll use Greenplum for that later. So let's start with just that setup. And then you're going to understand where I'm going. I have only 2 applications running in my CF right now. We're going to use this one in a few seconds. That's my machine learning piece of it. I'm going to start with my web console. And, oh, here it is, by the way. And that web console just has a US map. We'll show the suspect transactions here. We see them blinking. So let's start with just very basic test. I'm going to run my microservices, my emulation microservices. You're going to see it's adding 3,143 devices. If you ever wonder how many US counties you have in US, that's the number. And then it's posting transactions. We're able to capture the all green right now, but that's the baseline. Let's kill it and go for it. Okay, so all we have at this point, and let me find my window here. All we have at this point is a microservice transacting JFAR, another one showing on the map. Now I need to figure out how to train a machine learning algorithm out of historical data that is on Greenplum. And every time I transact something, a minute later is on Greenplum. So it becomes historical as I'm transacting. And then feedback the model and understand what I'm doing. So we'll start by basically deploying an application in Cloud Foundry that leverages Spark for machine learning. And if you're not a data scientist and you don't have a clue on how machine learning algorithms work, don't worry. It's really, really simple. I'm going to try to explain on the best way possible. So this application, all it does, it looks at the transactions that happened, all the transactions available in Greenplum, and it uses 2 variables. One of them is the transaction value. So $5 against $150, for example. And the distance from the home location. Your home location might be Las Vegas, which I doubt, but could be, for example, Bay Area. Could be New York. And it classifies the transactions by low, medium, and high risk as aggregating transactions that have similarity between low transaction value and low and very close to home location, for example, to transactions which are beyond $100 and executed in China, for example, where I currently live in Bay Area. And those are the transactions we're actually looking for targeting as possible frauds. Of course, a real-world fraud system would have more variables. We'll simplify it so it makes it simple for people to understand. Once we train that model with that, we basically output a file that's called PMML. And if you never heard about that, PMML is just an XML representation of a pre-trained algorithm. So it's something that you can, for example, train in Spark like I'm doing and evaluate in any other machine learning architecture. So we basically train the model in Greenplum, and we're going to evaluate in real time in Spring Cloud Dataflow. That's why I'm exporting it to PMML. So let me walk you through that application really quick. You might have noticed that let me start fresh here so you see in the back. You might notice that I already have that application running, and I apologize, but I really needed to train it before this happens because it takes over an hour to train. It's a lot of data. But I'm happy to walk you through the source code. And what we're going to see is that that application has an endpoint that I call the /model PMML that has the pre-trained model. But I'll walk you through how I generated and what the model contains, etc. If you get this part, the rest is 5 minutes, really simple, because the rest is Spring Cloud Dataflow. Super simple. So that application is, of course, a Spring Boot app. And I'm going to zoom in. Don't worry about it. So it's a Spring Boot app, very simple, that basically has one controller. Couldn't be simpler. And that single controller has two main methods. One of them is the one that I access to show you the existing model. And what it does, it gets actually the latest model from Redis. Simple as that. And the /train method, which is actually what trained the algorithm, basically calls this on Spark, and I'll show you the source code of that, and takes whatever is returned and stores in Redis. So that means I can be constantly training the model, and while it's training, it will always output me the latest trained model over that, because it grabs the latest trained from Redis. Once it finished training, if I start it now, in 1 hour, for example, we have another model trained. It's going to replace that in Redis, so we have the latest trained model always. So you can be constantly training, constantly learning algorithm. If you're scared of machine learning, you might be happy to know that the method that trains the model in Scala or Spark, it's less than 30 lines of code. It's really, really simple. And it just makes some queries in Greenplum. And you see there are some nasty analytical queries here. Gets connection to Greenplum, makes some of those queries, and then figure out all the devices available, all the transactions available, map transactions to devices, finds out home locations, that's where you mostly transact on, or more frequently transact on. And then for each row, or for each transaction, it trains the model with the distance from the home location. It's really simple. There's a method that takes the latitude and longitude and has a distance. It's really something simple to do. And the transaction value that is already sent by the device. So those two variables that I told you that we are training the model, where is it? The model with distance from home location and transaction value. We are basically getting them for each single transaction and outputting them to Spark. And then you say, hey, Spark, just test this with what I call a clustering algorithm that aggregates them with similarity and outputs a PMML. Is that okay? Clear enough? Great, because it's complex. So good. And if you ever wondered, this is, for example, one of the most famous algorithms for recommendation engines, for example. So if you're browsing stuff in Amazon and maybe you have a cat like I do. So you add cat food to your shopping cart, and when you check out, Amazon will look at similarities between what you bought and other people bought. And you might find out that somebody here, for example, also bought cat food, and you say, hey, that guy, similar to you bought very similar things over the last few weeks, also bought this thing here. Don't you want to buy that? Exact same algorithm, exact same thing. So at this point, we basically have an application in Counts Foundry which I can access an URL and give me a pre-trained PMML model. That's it. What else do we need to do? Well, a lot of things. And that's what Spring Cloud Dataflow is going to do to us. So we're going to start our flow by ingesting applications directly as they happen in Gemfire. So if you rewind this in 30 minutes, or maybe 20, early in the presentation, I showed you the baseline where we had an application transacted to Gemfire. Now we're going to grab each one of those transactions as they happen. And we're going to first add the distance from home location information to it, because it doesn't have. If I connect to Gemfire and show you the model, and we'll do it if we have time at the end, you show it that has basically transaction ID, device ID, value, and timestamp. That's it. But I was able to figure out the home location for the devices in Greenplum, so I actually can add that information here. And it's what we call enrichment of a pipeline. So an example of enriching a pipeline with the data coming from different locations. That's a custom application, by the way, that we're going to add to Spring Cloud Dataflow to be part of our pipeline. The rest, it's all reused. So after adding that information, I'm going to log it. So you see we're adding that information to the pipeline. But we're also going to tap out or take those transactions and start a new flow that will then run the PMML evaluation. After that enrichment, I should have the distance from a home location that I'm adding and then the value that was originally. Then I can match those two to the, to the two variables I have in my model. So if you look at my model, I have field 0 and field 1, which unfortunately are the names that Spark gives to the variables. I know it doesn't help, but trust me, it's distance from home location and transaction value. And as we trained, it created 3 clusters. One, and those are normalized values, of course, but one that seems very close to my home location compared to the others, and very small transaction value. This is cluster number 2, should be my low risk cluster. There is one that has a slightly higher transaction value, distance and transaction value. And there is one that is very far away and have high value transactions. And this, that in this case is cluster 1, or it's called cluster 0. I'm numbering them starting to 1, so this is actually our high-risk transaction cluster. So let's start with Spring Cloud Dataflow. Let's create that flow. First off, you're going to realize, as open Spring Cloud Dataflow UI, let me try to make this slightly bigger. Okay. Then you have a list of the applications that you can use to make your flow. So of course, somebody else already created an application that grabs file, FTP, JFile, whatever. And that's what we're going to be using. Many of those. I need to add an enrichment part of it. That's our custom application. We will do in a while. And once you have all those applications, then we can go and start dragging and dropping stuff to create our flow. But hold on, we'll get there soon. So we'll first bring our custom application that I promised to show you how to make a Spring Boot app, a Spring Data Microservice. So again, another Spring Boot app, very simple, that has one main class that I'm using 2 special annotations. First, I'm saying this is a processor. And second, I'm saying for this method here, receive your parameters from the standard input channel and write the results to the standard output channel. And this is what will make Spring Cloud Dataflow go to Rabbit, for example, which the messaging layer I'll be using here, creating a channel in, a channel out, and binding automatically for you, and making all the conversion, all the transformation, marshalling, unmarshalling, those kind of things. And the only thing I really do here is parsing the JSON payload, calculating the same distance, exact same method, calculate distance in kilometers, given the latitude, longitude, and then adding to the payload. I'm formatting the value, but I'm adding to the payload home location and distance, and that's what we're going to use to evaluate it. So last step before we deploy the entire thing, I'm going to go ahead to my, where is it? Let's say to it. Fraud detection, Data Microservices. This is the enrichment processor. Exact same application. I'm gonna Gradle build install. And install means I'm going to install to my local Maven repository. So as I register the application Spring Cloud Dataflow, I'm going to say, now I have an application that I'd like to use as part of my flow. I'm going to give it a name. Let's say Enrich. And then I'm going to point to my local Maven repository that has it. So I can be iterating on this application, publishing it to Maven as my CI/CD process happens. And then I deploy the new flow. It grabs the latest and deploy it as part of this, part of the pipeline. So as we've done this, we can either go to the UI again and register a new application here, or if you'd like to see the command line in action, we can actually just register and give it a Maven name. Now, if you do app list, you should not only see the file, FTP, Jamfar, et cetera, as you've seen. There's also a processor called Enrich, number 2 here. And that's what we're going to be calling. Cool? Okay. Now is the easy part. We're going to go to Spring Cloud Dataflow and create that flow. So, streams. And let me make sure there's an Enrich here now. Enrich, it's here. Okay. So we start with Gemfire. And I'm basically starting, let me call this from Gem. That's the name of the flow. And I'm going to connect to the Gemfire server running here. It's basically running on my machine. I have this on my /c names. And we're going to be extracting information from a region called transaction. And as we have name now, it's probably a good time to show it. So we can connect to Gemfire and see what we're ingesting in terms of data. So I'm going to connect to geo server. And I can list my regions. And I'm ingesting data from transaction. So let's take a look at that. I have 259 transaction events. They're partitioned. And what I really wanted to do is to show you what's coming. So all we have is the ID, as I said, device ID, value, account ID, timestamp. And that's why we're going to add the home location to it. So I'm ingesting this data from region name transaction. And it starts to write what we call a DSL for me. A DSL is extremely important because you don't want to actually drag and drop and do this every single time you want to deploy the exact same flow. You want to save this and be part of your script or your CI/CD pipeline. So you got to have a representation of what you're doing. That's the DSL. So as we ingest data from Gemfire, it's complaining that it needs a destination, another app. It's smart on that as well. And I can start now. Next step is I'm going to add that location information to it. And watch up there on the DSL as we connect. It builds that for you. And the next step, I'm going to log to show you what we're actually doing. So I'm not faking anything here. Validated, green. And then the next step, if you remember, I'm going to tap out, PMML, log, filter, etc. I'm going to save you time and my time as well. And let me use the DSL I generated before. This is also a great way to visualize what you're doing to explain people, because as you do this, boom. Looks great, huh? Yeah, so let me walk you through that again so we know what we're doing. Help me validate it. So, getting a source from Gemfire, that region. I'm going to enrich. I have no properties. I make the simplest Spring Boot application ever. But I'm going to log whatever comes out of that. Separate flow, we're going to do PMML. And which model I'm evaluating? Well, it's the model I showed you. Clustering service, local PCF dev IO, PMML, XML. like this. Exactly that. And then I'm taking field 0 and field 1, as you remember, the variables, which are here. And I'm mapping them to the distance from a home location at the transaction value. That makes a ton of sense. So that's it. Field 0 is my payload distance and the double value of it. And my field 1 is my payload.value. And all I'm saying is I expect an application/JSON result because I want to show you what's going on. I don't want to see some binary there. And then I'm going to tap it out again. And I really, so just to make sure we understand what's coming here, as we evaluate, it's going to output cluster 1, cluster 2, or cluster 3. If you remember correctly, cluster 1 is high risk, cluster 2 is medium, cluster 3 is low. I'm really only interested on the transactions that make that evaluation as cluster 1. So I'm filtering everything out that is not underlying output, and I'll show you that's the variable that the PMML model creates for the result. I want output result equals 1. That's it. I don't want to see any other transactions. That's going to filter out the low and medium risk. And the results, the ones that make it, I'm going to write back to Gemfire to a region called suspect. And that's what my application is watching for. We might already have some suspect transactions here because I ran this demo before for testing, but let's take a look and we'll see the number growing as we run, of course. Suspect. Yeah, I have 128 transactions. We'll see the value after that we create new, but that's the suspects. Okay, that seems very simple. Now, let's exit Gemfire. If you remember correctly, and let me make this easier for everyone to see, I only had 2 applications deployed in Cloud Foundry. Here we go. Only had 2 applications deployed in Cloud Foundry. Now, if I go to Spring Cloud Dataflow, first, create my streams. It basically shows now the streams are available. And I deploy the first one that reads from Gemfire. Deployment request sent. We'll do CF apps again, and we see magic. So now we have 3 new applications. They're named Dataflow dash name of my flow dash step. So from Gemfire, read from Gemfire, from Gem Enrich, from Gemlog. You see they're currently stopped, but they should be starting soon. One is already started, the other ones are on its way. And I'm going to start logging this guy over here. So when they're all running, we can actually see that we're actually enriching the payload with that. And then we'll deploy the other ones and see the complete example. As you see, they're all Spring Boot applications. Now we're streaming logs directly from Gemfire, so you can have as many instances that you have. You're basically getting all the log aggregators in place. Container became healthy. Thing seems we are online. Let's check the other apps. Seem to be all fine. Now, I'm going to keep tailing those logs, and we're going to run that test again that emulates some transactions. Let's see what's coming out of that payload. Now, we should be enriching the payload, but we're not doing any evaluation of the machine learning algorithm yet. So, adding those devices again. Few seconds. Now we're seeing transactions. Let me stop right here, go back to that log. And now we're seeing a few transactions. Let me zoom one of them. ID, device ID, value, account ID, timestamp. But now I also have home location in latitude and longitude. And based on that, I calculated distance. If you are a good observer, you'll see that I'm actually generating a lot of far transactions. And that's why I said initially that I'm generating pseudo-random things. Otherwise, we need to stay here for a few minutes to see fraud. I don't want to see that. So I'm actually generating a lot of transactions that are 400 miles in distance, 1,400 miles in distance. We might generate one or two that are home-based. Most of them are very far away. That's in purples, but that means we'll also see a lot of action in the end. Okay, enriched. Let's evaluate that machine learning algorithm. So I'm gonna deploy the next step. Result, actually the evaluation. And as we do it, CF apps again, 2 new applications at the very bottom. Oops. 2 new applications at the very bottom. Eval log and eval PMML. We can wait for those to start. Let me start logs. Let me start taking the logs so we know when they're ready. Maybe it's a good time to get questions. Any questions so far? You can also save them to the end as well. Okay. So container starting the health monitoring is starting. Another Spring Boot app. And oh, very important thing. As we created the streams before we deploy them, we already created the channels in RabbitMQ. That means we already have transactions on the pipe. Too late. Waiting for the application to come up, so we should already see some data. That's based on our first example. Same thing will happen as we add the third flow. That means that if you actually, for example, doing a new deployment for an application, not doing blue-green, you actually have some downtime on that, your transactions are actually waiting. In this case, in RabbitMQ, for example, as the application comes up, it all works. So there's an additional high availability layer here for that. The other thing I should show you, before we show the transactions, is that I actually have a Rabbit service available here that it's being automatically bound to every single application Spring Cloud Dataflow is deploying. So that's part of the magic. It could have Kafka, it could have anything else. I'm also binding it to Redis, as you can see, so I actually have 2 services, but Rabbit is first, so it has a precedence. If Rabbit is not available, I can do the other one. So yes, please. $16 gig. And we will have 9 applications in PCF dev. So by the way, all this work is open source. It's on my public GitHub repo, so you can reach out later. I'm happy to point you to that. So let's take a look again at some of those results. Now, instead of only having ID, value, account ID, timestamp, home location, and distance, now we have a new variable called underline or underscore output that has a result that in this case mapped to cluster 1 because I'm far from my home location and I actually have almost $100 transaction value. Most of those will map to number 1. Sometimes I'm getting number 2 and number 3 just because I'm generating a lot of those, as you know. But I don't care about the other properties here. All I'm going to do now is actually filter the ones which underscore output dot result equals 1. And of course, you can do more things if you want it as part of that. So now we have that. I'm going to deploy the last step of the pipeline that we're going to filter those transactions. Already some transactions on the pipe. So I will expect to see soon a few suspect transactions filling up here. But don't look now because we'll run the entire thing again to see that action live. So let me hide this for now. CF apps. 2 new applications starting. I don't have a log for them. I just write to Gemfire, but I'll keep tailing the logs to know when they are ready. And if there are any other outstanding questions, I'm happy to take them now as well. Please. Of course. You can have, so Spring Cloud Dataflow, you can define as many streams as you want, right? You can have different sources come from different places and then taking different actions and being handled in a different way. And there are a few patterns you can use if you want to join two different streams. So I have two sources that end up on the same queue and joining. You can actually do that with a custom application as well. So there are ways to do that. Yes, sir? Absolutely. So that clustering microservice, that clustering service that generates the machine learning model evaluates, that was pre-deployed in in CF. You can actually do many different things. If those are basically web-based microservice, you have a controller with RESTful endpoints. You can just call an HTTP client model that does that for you. Or you can actually tag them as data microservices and consume them right away, which is the way I would recommend, so you avoid an extra hop to call them. Or there are many different ways. You can make them consume directly from the queue. I would just tag them and make them a data microservice. So our other applications seem to be up. Oh, okay. So we have some fraud here, but I'm going to refresh this thing and do it again. So now let's restart that exact same demo. Oh, stop. I know you're anxious, but let's take a look at Exemplified. We had 128 suspect transactions, if you remember correctly. That's an easy name to remember, easy number to remember if you're in IT. Now I can describe that region named suspect 176. Yes, so we got a bunch of frauds. So now yes, let's start that emulator. Adding a few devices. And I'm expecting to see a lot of reds, so don't be scared. Go back. Okay, starting. More reds. Plotting. And let's see how real time this is, or how much time behind the transactions are we in evaluation. Stop. Go back. A few. Done. That's it. Cool. Does it make sense? How long that would take you to do that in your existing enterprise integration architecture? Okay, well, in my point of view, once you start doing those things and you have the flexibility to change, the tap log thing is my favorite for troubleshooting. You know what's going on in a specific part of the flow. You can start taking part of the flow and scaling those. I just deployed them as one instance. They're all in PCF dev. I could scale them differently. I could turn on auto scale. I can start monitoring metrics. I can make circuit breakers and CFC registers part of it. Have a bunch of possibilities. But then you can start, as you're able to do this kind of real-time thing and integrating applications with Spring Cloud Dataflow, you actually start to walk towards this end-to-end cloud-native architecture, where you might have in the first layer your business microservices, as I usually call them. They're really doing, realizing business concerns and business-related activities, which in a web store might, for example, might be receiving orders, handling payments, inventory, shipping, so it can split different responsibilities, different microservices. In a second layer, over the exact same platform, making the full benefits of a platform like any microservice, you can have a layer of data microservices which are messaging based, which actually take data from your existing business microservice like you asked, connect to data service, to other backend services, to other microservices, and then you can start orchestrating things over a well-defined visual UI. Yes. Well, that's up to. So understand that the platform plus the add value on the platform, Spring Cloud Dataflow in this point, is basically give you an abstraction layer on top of your own infrastructure or could be your own provided services or services you actually provision through the platform. That being said, it means it really depends on what your network is. It depends on what your backend services promises are or SLAs are. Mm-hmm. Yeah, sadly I know that well. Huh? No, BPL is a language. Oops. It's a representation of a metadata language for orchestrating those things. It's a standard that was tried to push in old SOA days. That had many issues and not became something standard de facto. Here we actually have a product that basically handles a much higher abstraction layer. It's not representing, it's orchestrating that for you. And it's orchestrating those calls based on a existing messaging layer or a mesh layer they provide, plus microservices. I'll tell you that it can totally replace a BPL-based model that's running on a ESB, for example, that orchestrate that within a cloud-native architecture, which makes much more sense than you can scale independently. Yes. Yep. Yeah. Oh, yeah. I'm trying to please a lot of different audiences, so I'm getting data and enterprise service integration together on a single use case. A lot of simple use cases are just orchestrating different microservice calls, like you mentioned. Or you can use that for connecting data services as well. So I think once you have on the platform services plus like backend services plus small applications or microservices, and they all have a route or they all can be automatically bound to your application, then you have endless possibilities. And anything you do is just another application. So yeah, I think the main use cases are generally enterprise application integration, so EAI use cases. There's a lot of untapped data possibilities here to be explored as well. Please. Mm-hmm. So we are operating on top of a very well opinionated platform. I wouldn't take any existing ETL process, for example, and try to port into microservices. Most of the time, they're not ready. They're not applications that can be scaled. They're not stateless applications that expose all the states to backend services. They might use local disk. They might hold their state on its local memory, whatever. So I think it's a re-architecture exercise rather than a migration exercise. But I learned that a lot of those ETL applications, they're extremely data-centric. They're most SQL statements can be actually extrapolated and refactored into small pieces of software, algorithms that actually work. That, for me, that's one of the reasons that Spark is getting so popular, because what people used to do with a lot of SQL and data wrangling, etc., they can just because very easy functional language algorithms with Scala and Spark. So one of my reasons for bringing Spark to this is actually to demonstrate that as well. Does that make sense? Okay. There's you, but that was somebody else. Hold on just a second. Yes. Absolutely. So let's say you deploy this first version of the pipeline, right? You actually working on your model, your machine learning model. You add a few more variables as part of that model. You can actually just repush that application to Count Foundry. It's already bound to the services, already consuming data from one right to the other. You can do a blue-green deployment. So say, for example, 10% of your route requests will go to this new one, and then you can start draining the old one and starting pulling more requests on the new one. You can also create a new tap. So you can still allow that use case to happen, but you create a new tap, deploy the new data microservices, so you start getting those flows there, and then you kill the rest of the flow, the other tap, you can remove. So there are many different ways you can do that. It's a 1.0 GA product. So a lot of those behaviors, I think, will actually work on putting the next feature releases of the product as built-in capabilities. So we're opening new possibilities in terms of enterprise integration based on cloud native, but understands the 1.0 GA product. It's totally awesome. My experience is extremely stable, but we already have a full roadmap to look on new features that we want to implement. So no, I don't know. I went quick through that. I should have stopped. But when I clicked deploy, there was a box and saying properties right before I click deploy again. I could specify a property there saying, for this specific step, I want 4, 3 containers, 5 containers. Usually customers like to do is they start maybe with a baseline number of 2, 3, 4 containers. Never 1 because 1 is not highly available, of course, but start with 2 or 3. Figure out how the load is, or you can actually turn auto scale, so it figures it out for you automatically. If you want to do that manually, see how the load is. You can start getting metrics out of your containers immediately as they deploy. And then you can just do CF scale, or applications manager plus apply. Boom, it scales. It's really fast. But you asking about also how do we partition data, right? So, in this example, if I would scale, what I would do is I would add few containers to each step, but you can actually specify to Spring Cloud Dataflow saying partition data by, in this case, customer ID. So I have all the customers with the single node, or for example, by device ID. So my analytics makes sense. And what it happens is, it gets to that point, it knows how to intelligently route the requests that come with a device ID 1, for example, to node 1, 10, 20, 30. Maybe the request with device ID 32 goes to the second node. It knows how to distribute that evenly for you. And then you can start scaling from that. And then, of course, your scalability will also depend on the transport layer. So for a lot of reasons, I'm a strong believer of Kafka in production environments for this kind of use case. I think we're out of time, right? 1 minute. You guys want to give me applause for 1 minute or something? Thank you.